Okay, so we start. Once more, sorry for the delays. Um, I hope you can see my screen. So for week 3, we are going to deal with deep learning. So we start by asking a question: what is deep learning? We see that nowadays computers can learn almost just like human beings. They can be trained with new skills, just like human beings, and they end up performing better. So what is deep learning? Deep learning is the ability of the computer to learn about things just like we human beings do. So if I could summarize, I would say that deep learning is mostly concentrated on how computers are able to learn, just like we human beings are able to learn. In week 2, um, for in week 2, some of these concepts were discussed that computers do have the ability to learn, and the way in which they learn is what we refer to as deep learning. So for this week, we are going to explore how this happens. So we ask the question, how do computers learn? Yeah. First, let's see how human beings learn, because we can't be able to answer this question without knowing how we as human beings learn. So I will advise you all to put on your imagination caps and see how we move ahead. So for some seconds here, imagine you see an animal for the first time. What happens? Your brain stores images and behaviors of that animal. Another example, to continue, maybe someone might tell you the name of the animal. Example, a whale. Let's say in the next couple of days, you see more of that animal. Anywhere you go, you'll be able to identify the animal, right? So, for example, for every one of you here, there, there has been a first time for you to see a dog, a cat, or even a mouse. Yeah. But um, maybe you saw it for the first time. There has been no magic for you to know that, okay, this is a dog or this is a cat. But over time, maybe someone will tell you the name of that animal, maybe your parent or a teacher, or you see it in a movie or a friend. Yeah. um, you learn the name that, okay, that animal is a rat. Okay, this is a dog. A dog has teeth and it will bite me. A dog runs very fast. You know their attributes, you know their characteristics. So what happens? You store the name, the image, and the characteristics of that animal in your brain. Yeah. So this is how human beings learn. And by way of mean, this is the same way that children do learn. This is how they learn new languages. This is how they learn to identify people, things, objects. And as you grow, you become accustomed to this way of learning. So how do we achieve this type of learning? We receive data through our sense organs and store them in our brain. Yeah. So if I may ask, sorry, what are our sense organs? We have our eyes, we have our mouth, we have our nose, we have our bodies to feel, we have our ears to listen. Yeah. So because of our sense organs, we are able to recognize people, sound, our environment, images, and all these things. So if you look at the picture here, we receive information or we receive data through our sense organs like our eyes, our nose, mouth, ears, our bodies, and we store those information in our brains. And the brain is able to process that information into something useful that you'll be able to understand and work with. The brain has a lot of nerve cells or nerves called neural networks that allow us to learn and store pattern of things we have learned previously. So if we come across the same thing or similar one, we will be able to easily recognize it. So earlier I spoke about you learning about a dog for the first time, like the name of the dog, its image, and all those things. And whenever you see another dog, you will say, okay, I've seen this type of creature before. Or maybe even if you see the same dog, you'll be able to know that, okay, even though these animals are dogs, but this one's name is Rex and this other one's name is hmm, maybe I don't know some other name. For instance, Scooby. Yeah. So you'll be able to know the differences between these dogs. How do you know that as a person? How does your brain allow you to know that? Your brain has some nerves, it has some veins that are referred to as neural networks. These are veins that are connected, and its job is to pass information from one point to another. That's basically what it does. Yeah. So this is how the brain learns. When you receive input through your sense organs, your brain passes those information through your neural networks, and your neural network in turn able to store patterns. It's able to it is able to transmit this data within parts of the brain, sorry, that could store patterns and make you know that, okay, I've seen this previously. It will be able to make it will be able to enable you make better decisions. So we move to the part where we ask, how do computers learn? But before we dive into that, based on how human beings learn, do you have any question or comments before we move further? So do you have any question or comment with regards how human beings learn? Because we are going to use these examples that I just made to to explore how the computers learn. And it will be more easy for you to be able to know how computers learn if you have a firm knowledge with regards how we as human beings learn. So I'll give some seconds and for you to come up if you have any question or comment. Feel free to talk or you state it in the chat area. Hello. So do I need to call names? I'll start with Michaela. Is this okay? And Madeline. Okay, Michaela says it's okay. So what about you, Madeline and Iron Faith? Okay, Iron Faith, no questions here. And Madeline, are you online? Okay, we move ahead. So we move to the section about how do computers learn. Okay, so basically, just like human beings, computers are fed lots of data. Example, text, audios, videos, photos, etc. Yeah. Machine learning techniques are used to train the computers to store this data in their brains. The brain of the computer is normally called a CPU. But to train a computer effectively, it needs an advanced brain called a GPU. So, what do we get from this short note? We see that we human beings, we are fed data. How? Through our eyes, through our nose, through our mouth. Yeah. For instance, when you smell that sweet soup, you are being fed data, and you know exactly what type of soup you are smelling. Yeah. When you see a color, you know exactly that, okay, this is blue, this is red. You are being fed data. When something burns you, for instance, if you put your hand on a fire, or if you put your body against a cold object, you know that something hot or something cold has touched my body, and you'll be able to distinguish between heat and cold. So in this same vein, computers are fed a lot of data through text, audios, videos, photos, etc. And they learn through these things that they store within themselves. Yeah. So machine learning techniques are used to train the computers to store this data in their brains. And from here, we learn that the brain of the computer is normally called the CPU. But to train a computer effectively, it needs an advanced brain called a GPU. So even though we can use a CPU to train a computer and to do machine learning and artificial intelligence, if you want to do it effectively, you need a computer that has a brain called a GPU. Okay, so I guess we move. When the computer has these data, they are stored in their memories just like human beings. Of course, you all know that human beings do have memories, right? We are able to store long-term information and short-term information. Um, you know how to walk, you know how to talk. These are all memories. They are long-term memories that are stored in your mind. Yeah. But there are also short-term memories that you get, that you store for a short period. They only become long-term maybe when you come across them more frequently. So we say deep learning is used to enable the computers look at attributes and features of the data. So if it comes across the same kind of data, it can easily recognize it and make informed decision. So let's break this down. Yeah, we said that deep learning is used to enable the computers look at attributes. So what are attributes? Attributes are basically characteristics. For instance, hold, if you look at what should I say? I want to give an example now. I'm thinking of something that could be more easy. If you look at a chair, for instance, you'll notice that most chairs do have four legs, yeah? Or let me give an animal in this case, since we started with animals. If you have a dog and I ask you to give the attribute of that dog, you tell me that dogs do bark, yeah, they bark. You tell me that dogs can growl. You tell me that dogs can bite, dogs can run, dogs have Dogs do have a hairy body. You tell me that dogs are friendly. Some are friendly, some are not. But you tell me that they are friendly to those that own them. These are the attributes, these are the characteristics. If I ask you to tell me your own attributes, you'll be able to tell me that, okay, I am a nice person or I am a bad person. I am dark in complexion, I am fair in complexion. Okay. I am intelligent, I am not so intelligent. You'll be able to tell me your attributes. So in the same way, when a computer looks at a data, meaning the text or the audio or video that you give to it, it will be able to tell you the attributes of that data. Yeah. And also the features, how it looks like. Okay. How does this data look like? How can I describe it in depth? So if it comes across the same kind of data, it can easily recognize it and make informed decisions. Just like if you come across someone for the first time, you are able to look at the person's attributes and the person's features. That is the reason why you are able to see that person at another time, and you're able to say, I know this person, I think I've met you before, I think I've seen you before. So this is the same way that computers do learn. So if computers learn this way, we need to know how does it happen? Yeah. How do they learn the same way that we human beings learn? So earlier when I showed you this picture, this one, we talked about neural networks, right? So here we are going to expand on that area. So we have what we call neural networks in the computers. Yeah, this is how they learn. When the computer stores data in its memory, it trains itself using advanced mathematics and statistics to learn patterns and different kinds of data, sorry. It trains itself using advanced mathematics and statistics to learn patterns in different kinds of data. So if it sees that data, it will be able to remember it. Okay. So this expands on what we discussed just now, that it looks at attributes and features. Yeah. It's the same thing that we are talking about here, that it uses advanced mathematics and statistics to learn patterns in different kinds of data. So what the computer uses to learn about the features and characteristics and attributes of a data, it uses advanced mathematics and statistics to achieve that. So that if it sees that particular data, it will be able to remember it and also make informed decisions about that data or on that data. So we said that neural networks are what allows the computer to see patterns and connection in its memories that will allow it to recognize similar data. Let's say you store 1,000 photos of different kinds of dogs and 850 sounds of how dogs growl and bark. Okay, so this is interesting. Let's say you are able to store 1,000 different photos of different dogs, for instance, and you also store barking sounds of different types of dogs, how they bark, how they growl. Yeah. Let's say you store those data in the memory of the computer. What the neural network will do, it will use mathematics and statistics to go through all that data, and it will train itself. If it hears any barking sound, for instance, if the computer hears any barking sound through its microphone, yeah, what will happen? It will be able to compare it with the sounds that it has and say, okay, this is a dog. This sounds like a dog. So I'm going to say that a dog is barking. Or if you use a camera and it sees a dog, how? Through its features, maybe its ears, its nose, its hairy body, and all that, it will be able to predict that, okay, what I'm seeing now, based on what is stored in my memory, it looks like a dog. So how does it achieve it? Using advanced mathematics and statistics. So we say the neural network trains the computer to look at specific features of the different dogs in all photos, like tail, ears, nose, hair, color, teeth, etc. Okay? So the neural network does what? It trains the computer to look at specific features. It also collects the pitch of the growls and barks. So if you feed it a new picture or it hears a dog bark, it will recognize it. It will be able to tell you that, okay, this is a dog that is barking. Likewise, if you store the pictures and sounds of a cat in the memories of the computer and you feed it a new data, for instance, it will be able to tell you that this is a cat and this is how a cat sounds. So now we have a more interesting but complex part that we are going into, which are the types of neural networks. Yeah, I will see how best I will try so that we can simplify this area and make it more understandable. So we have the types of neural networks. Let's look at one. We have a feed-forward neural network. We have convolutional neural network and recurrent neural network. Okay, so we are going to look at these three. Actually, there are lots. We have up to 7, if I'm getting right, but the most common ones you come across are these three, which are feed-forward neural network, convolutional neural network, and recurrent neural network. So do not get scared or intimidated by the picture you are seeing, because what you are seeing here looks like a mesh where all the circles are connected. But if you look at it more carefully, you see that you have the input layer at this side, the extreme end, and in the center we have the hidden layer, and we have the output layer. So we are going to describe how this happens, because this is just trying to describe how neural networks, how they work. Remember earlier I said neural networks connect with themselves, yeah, in order to enable the computers learn. Okay, so we start with feed-forward neural network. So this is the earliest and simplest form of neural network. Okay, how does it work? Data is passed from one neuron to another. In this case, what is the neuron? Is this the neurons are the circles that we are seeing here? These circles, they are called neurons. Just like our brain, in our brains we have neurons. So in this case also, the circles we are seeing here are models or examples of neurons. Yeah, so data is passed, for instance, from one neuron to another. A neuron stores attributes of a data, and the connection of neuron is called neural network. For instance, the connection from here to here and here to here to here are what we are referring to as neural networks, because they are connecting the neurons. Okay, so if you look at these neurons, we have the input layer, we have the hidden layer 1, hidden layer 2, and the output layer. So meaning we are going to collect input here. These hidden layers are going to process these inputs, compare it against themselves, and it will be able to give you an output. So how does this work? Let's say I show the computer the picture of a dog here. What will it do? It will compare it against different pictures of dogs that are stored in my memory, and it will give you an output that will show that this is a dog. So this is what this particular model is trying to talk about. So it explains, it says communication flows from the input layers, pass to the hidden layers, and finally to the output layers. So when the computer receives data in the input layer, it compares it against the hidden layers and finally comes out with an output, just like I explained earlier. So where is this applicable? That is a feed-forward neural network. It normally applicable if you want to use it to make predictions and if you want to use it in medical diagnostics. We have convolutional neural networks. So we said these are neural network. These neural networks are mostly used to identify images and objects. They look for patterns such as curves, edges, lines, etc. To make the objects, it takes the object apart by features and trains the computer. Then it assembles the object again to understand it better. So this type of neural network normally works with images and objects. What does it do? If it takes an image, for instance, it will split the image into different sections. It will look for curves, objects, just tiny little bits of ways to understand the object or the image. And then it will be able to check against its memory to see that, okay, it will be able to train the computers firstly and store those information. And whenever you input a new information of that particular picture again, it will be able to tell you that, okay, this is what you are checking for. This is a rat or this is a snake. Yeah. So let's see how it works. In here, we can see that this is a picture of a bird. Yeah. So what do? We feed the computer as an input. We feed it through the neuron. What does the neuron do? It takes apart different features of this bird. For instance, maybe the eyes will come here. Maybe the colors of the bird will come here. Maybe the shape or the curves of the bird will come here, and different characters will come. Different parts of the different parts of the bird will come to different neurons. Okay, and what will happen is that it will pass these different features to the hidden layers, and then this hidden layer will have maybe different animals. We have dogs, cats, birds. What it will do, it will compare it against the different type of features that it has and bring out the output. And it will be able to predict that, okay, out of all the animals that I have, I've been able to see that this is a bird because when I compare it against the pictures of birds that I have in my database, the features look similar to that of a bird that is stored. So it will give out an output that, okay, this is a bird. So what we see here is that after all the layers process the image, the convolutional neural network uses this information to make a decision, like classifying the image as a cat, dog, or other objects. In summary, convolutional neural networks are like a smart scanner that looks at an image piece by piece, recognize patterns, and then puts it all together to understand what the image is showing. They are particularly good at tasks like image recognition and object detection because of how they handle visual data. Okay, so next we have recurrent neural networks. Before we go to recurrent neural networks, let me come back to you again and ask if you have any question so far with regards to what we've done. Is there any question or comment that you like to know about with regards everything we've discussed so far? If you have any, you could put it in the chat box and I'll respond to them. Yeah, okay. So we have recurrent neural networks. So recurrent neural networks are used to handle data that usually comes in sequence. Example, sentences, paragraphs, words, music, time series, data, etc. So if you notice something here, you notice that convolutional neural networks are used to handle mostly images and videos, whereas recurrent neural networks are used to handle um, sentences, paragraphs, words, and these things. Yeah, they are great for tasks such as text recognition, chatbots, speech recognition, weather forecasting, and price predictions. So this is how a recurrent neural network looks like. You have the input layer, the hidden layer, and the output. What makes neural networks special? So neural network mimics how the brain works at a deeper level, thus deep learning. So this is what makes a neural network special. It's it is used to copy how the brain works, and it does it in a very perfect way to make computers more smart and intelligent. So we'll look at the important functions of neural networks. One of them is activation function, the other one is loss functions, and the third one is optimization techniques. So let's just briefly look at them and move ahead. Activation functions. So we say think of activation function as gatekeepers in a neural network. They decide whether a neuron should be activated or not based on the input it receives. Okay. And loss functions are like report cards for the neural network. They tell the neural network how well it's doing by measuring the difference between its prediction and the actual result and the actual correct result. The network uses the loss function to know how far it is, how far off it is, sorry, and what needs to be adjusted to improve. So what happens is that the loss function will be like an assessment, yeah. It will be able to assess that, okay, um, the prediction that the computer made is right or wrong. And if it is right, it will let the computer know that, okay, what you have done is right. If it is wrong, it will also inform the computer that this prediction is wrong. And this will enable the computer to learn more better. So just take this like a lesson teacher who will ask you 2 times 1. And if you say 2, it will then the lesson teacher will tell you that yes, you are correct. And maybe they will give you a reward, a sweet or something. If you say 2 times 1 is 1, then they will correct you. No, this is wrong. 2 times 1 is 2. Then they will ask you again 2 times 1. So you find out that with repetition, you'll be able to answer a whole lot better. That's why they are saying this is like a report card. Optimization techniques. So optimization techniques are like coaches that help the neural network get better over time. They guide how the network should change its internal parameter like weight to reduce the loss function and make better predictions. Okay. Without optimization, the network wouldn't learn from its mistakes. So it wouldn't improve over time. So just like I mentioned a while ago that this loss function is, they say, it's like a report card, yeah. So now let's just assume that optimization technique is the teacher. It will be the one that will correct the computer, yeah, that you have made a mistake, so that you will not have a lot of mistakes, which we normally refer to as loss function. So this loss function is meant to calculate all the mistakes that have been made, and this one, the optimization technique, is what will correct you. So we are done with the theoretical sides of deep learning. Um, I'll try to just show you a brief, I don't know if I could, of how it works. Okay, let's see. So we need to get, for instance, we are in the part now where we are going to do hands-on, which is why I asked you all to work a little bit with Python and see how it works, so that it won't be strange to you. So what we need for our practicals, yeah, we need a Python programming language. We need a Jupyter notebook or Kaggle notebook. We need, there are some things that we refer to as libraries. Libraries are codes that other people have done that will make our own work simple, wherein we don't have to code everything over and over again. And we need data set. So data set is the data that we store in our computer's memory. Remember, we talked earlier about storing data in the computer memory, right? So data set is what we use. It's like a sample data to store data in the computer's memory. So, okay. So before we move to the practicals, I would like to hear from you all what you think so far about what we have discussed. What you were able to understand or learn. For instance, anything on the, be it on neural networks or on the type of neural networks. Mm, these things are like, what have you been able to learn so that when we go to the practical, it will be a whole lot simple. And I'll also like to hear from you if you like us to go through the practicals today, or we postpone the practicals for our next class, which I'm sure should be scheduled for Tuesday, if I'm not mistaken. So I'll start with I'll start with Michaela. What have you been able to gather so far on what we have discussed? Anything? Be maybe you can talk about how human beings learn, or how computers learn, or the neural networks. And after that, we will go to Madlib. You can unmute your mic.
I was able to learn that computers also learn basically almost the same way as human beings learn, because they tend to store data, example, text or audios or videos or anything that you feed into it. And the machine learning techniques, mm, they help to train the computers on the data that you've inputted into them. Yeah. That's all.
Okay. So do you have any question, or are you okay with what we have discussed so far on the different topics for week 3?
Yes, I'm actually okay because I'm trying to get everything and know that speed for neural networks pass from one neuron to the other, and the other one um takes the data piece by piece and then tries to put it all together into it. So I guess I'm okay.
Okay. So finally, do you should we continue with the hands-on today, or do we do it on Tuesday?
I think we should do it on Tuesday so that we'll be able to
Okay,
research more
okay,
and be
okay,
prepared.
okay. Thank you. So, what about you, Madeline?
I think what stood out to me most the entire class was when you were talking about neural networks and the types of them and the different things they do. So, like in my brain, I was able to kind of like piece together maybe somewhere I've seen something similar and identify, oh, so this was the type that was used in this scenario, this scenario. It was enlightening because the knowledge was there, but through your explanation, I was able to like make more sense of whatever I just like read online about them.
Okay.
So when you explain that, I was able to like understand more and piece together, like create a more detailed structure of them in my head.
Okay, that's great. So, do you have any question so far on what we've done?
Um, you were saying something about the neural, like they use the neural networks for computers to identify images in medicine and diseases and stuff like that.
Yes.
Is it something we're going to learn here, or is that too advanced for a beginner level?
So we are going to learn the some of it here. For instance, there is one that is called convolutional neural networks that mostly deals with images, the one that
Mm.
has had the picture of the bird. Yeah. So we are going to do image classification in the practicals. So you will see how it works. And we're also going to do in week 4, we will do something on natural language processing.
Okay.
Yeah, where you will see how recurrent neural networks do work. So yeah, we'll cover some of them here, and this that will give you a good footing for you to be able to learn on your own as you progress in your career later on.
Okay. Thank you.
Okay, so do you also think that we'll keep it for Tuesday with 3 practicals?
Yes, I think that would be best. Yeah.
Better. Okay. And finally, what about you, Anya, Ayana Faith?
When you got to the part where you were explaining about how computers learn, and you talked about the brain of the computer is normally called the CPU, I had to go search when you were saying the brain is more advanced, the GPU, which was the
Yes, Anya, you were saying something.
Oh, sorry, I was having a problem with my internet.
Okay.
I said when you were explaining about the how does the computer work, and when you got to saying the CPU is the brain of the computer, I wanted to ask a question: why we need advanced graphical processing unit?
Yeah.
But I didn't want to spoil your flow.
Okay. So basically, we normally make use of. I spoke about a convolutional neural network that uses mostly pictures, right? Where the
Okay, sir.
computer will take a picture as an input or a video, and it will process it and be able to give it as an output. Let's say it will be able to predict that. For instance, if you feed it the picture of a bird or a dog or even the face of a person, it will be able to give you the prediction in an accurate way that this is a dog or this is a mouse or this is a person, right?
Okay, sir.
Yes. So the CPUs on their own are not able to handle that particular task. That's why we have GPU, the graphical processing unit. Yeah. I was just trying to simplify it that it acts as an advanced CPU because it will be able to. They built it for that particular purpose. It's built to handle the work that has to deal with images and video processing. Because let's take, for instance, that you have to go through something like 1,000 or 2,000 or 10,000 pictures for you to make a prediction. The CPU will not be able to handle such a task. But on the other hand, a GPU will enable you to perform that particular task. But when we come to convolutional neural network, you will see exactly how that works and what I'm talking about. There are certain tasks that you want to do. The computer will tell you that you do not have a GPU installed in your computer. So you won't be able to perform that particular task.
So
I don't know
the
if,
difference between the recurrent neural network and
yeah.
the feed forward network is that the feed forward neural network is it uses data that is passed from one neuron to another, and the recurrent uses a sequence of it.
Pardon?
You said from the slides, you said the recurrent neural networks they handle data that usually comes in sequence, and the feed forward neural network handles data that pass from one neuron to another. It's something similar, but they are not similar at all.
Okay, so let me go through it again with you. Let me find that section. Okay, so I guess you can see my screen here. So what we say here is that the okay, so we spoke that the feed-forward neural network, it passes data from one neuron to another. Yeah, and also it contains 3 layers connected to process data, and these are the 3 layers here. We have the input, and these, even though they are two, they are the same. They are referred to as the hidden layers, just that you have layer 1, layer 2, and they can be more than 2 actually, but they are referred to as the hidden layer. That's why they have the same color, blue. We have the output. And also, we learned that communication flows from the input layers, pass to the hidden layers, and finally to the output layers. So when the computer receives data in input layers, it compares it against the hidden layer and finally comes out with an output. Okay, so this is the area where I said that feed-forward neural networks are usually used to make predictions and medical diagnostics. So let me give a real-world scenario on them. Basically, for instance, if you want to predict the price of a house, yeah, what it will do is that it will look at existing data or features of that particular house. For instance, it will look at the size of the house, if it's a big house or a small house. It will look at the number of rooms. It will look at the location of the house, the area in which the house is situated. How does it look at it? You will have stored, let's say, maybe 1,000, 10,000 different houses. So if you feed the computer with a data that has some of these characteristics, it will be able to use those different characteristics like the size of the house, the location of the house, and be able to make a prediction based on past data that are stored in the computer already. Maybe it will use mathematics and statistics to give you an average price that, okay, based on what I'm seeing in the computer, I think this house is going to cost 3,000 US dollar or 2,000 based on the features that the house has. Okay, so that is how it works. That's why we are saying it's normally used to make predictions and also used to make medical diagnostics, like to predict whether something that you are seeing is a cancer or something based on, or to predict the blood type, for instance. Yeah, the blood group, sorry, or to predict some certain diseases. That's why we say they use it normally in medical diagnostics. And for recurrent neural networks, okay, we say that they are used to handle data that usually comes in sequence. So we gave examples here like sentences, yeah, paragraph, word, music, time series data. They are great for tasks such as text generation, chatbots, speech recognition. So now, for instance, if you are using something like Siri, or if you have used it before, something like Siri or Cortana in your Windows, or even your phone, most of the smartphones now do have speech recognition, where it will be able to recognize your voice. Yeah, but it looks for sequence. How does it recognize your voice? You have to talk to it more often. The more often you talk to it, the more it understands your voice, because it stores your pitch. It stores the sequence, the patterns in your voice. Okay. The same thing goes with music. Some apps are able to know your music listening pattern. How? Because it stores the way you listen to music. It stores the different sounds and rhythm that you listen to. And through that, it will be able to predict what music you love to listen to. And it will be so good at it. Okay. So, whereas the first one, feed-forward neural network, is usually used to make predictions based on, let's say, past data that are stored and with its features. Recurrent neural networks look for the sequence instead of just the feature. How often do they occur? So I don't know if this answers your question.
Yes, thank you very much.
Okay. So I think what we'll do, in our next class, we'll focus on the hands-on, where I'll solve a particular one. For instance, I'll solve an image classification AI, and I'll walk you through it. And if you are also able, you will also be able to use maybe Kaggle or Jupyter Notebook to to follow along and do the examples. And you also have your own AIs up and running if you have not yet done one before. So with this, I think the class has come to an end. And I want to thank you all for participating. And I hope you learned a lot. Yes, Madeline.
Yeah, I have a question. My hand has been up for a while.
Sorry, I didn't get it. Okay.
Yeah. So, where do we get data sets from?
Okay. So
do we have to create our own, or is there like pre-created data sets we can download and use?
Okay. So with regards images, for instance, in our next class, I will show you how to use Python to get your data sets to your camera. For instance, I'm going to use my computer. It will take pictures of me, and through that, it will be able to recognize me. For instance, when it sees my face, it will show my name. Okay, it will classify me based on data that it will take on me. I think within some seconds, it will take up to 200 or so pictures of me. And you could also get data sets from different. You could create your own data set if you want, although that will take you time, because a data set is data that has been existing for over a period. So you could take your data set from sources like Kaggle. Okay, I will put the link in the chat box. Let me go to it quickly and put it for you. There are a lot of data sets there that you can check, and you can also use YouTube to learn about how to make use of those data sets. Let me go to the link quickly and show you. Kaggle data sets. So Kaggle is one of the easiest ways for you to learn about artificial intelligence and machine learning, because they have examples on YouTube and they have free data sets that you don't need to pay for. The only thing, you will need lots of data to download some data sets, because sometimes they will be 1 gig or 500 megabytes and those things. So this is a link. I'll also forward it in the WhatsApp group now. Okay. So you could visit Kaggle and see data sets there that you'll be able to download into your computer, and you also be able to, if I am you, I'll go to YouTube and learn how to use Kaggle to work with artificial intelligence, or how to do machine learning using data sets. Then you see that you start something. Yeah. So is there any further question? Or are there any further questions from you guys before we close the session? Okay, I guess the answer is no. If you have any questions,
I
yes,
have a question. Some of the links you sent today or yesterday to practice Python, some of them are not available anymore on the site. I think the only one that is okay, two of them are actually working. Udemy and the solo learning. But the Udemy are also having problems. 1 minute it's working, the other minute the site is not working. And I thought it was my internet, but it was not my internet.
Oh, okay. I will check them up here. I got them from Joy. But what I'll do, I'll check them up and see what we can do about that. So if you have any more questions, you can please ask in the group, and we'll always be there to respond. So with that, I want to thank you all for participating, and I hope you go over what we've done, see what you could learn, and visit the link here, Kaggle, and see what you could discover there. Okay. So bye to you all.